तो आज हम डिस्कस करेंगे विल कंटिन्यू आवर डिस्कशन ऑन geomorphological mapping and as you guys know geomorphology is the field of geology, and it can also come under physical geography, and it deals with the topics that are covered in the physical landforms that are result, as we have seen, different processes, and also various rock types that are result of these features that we call the geomorphological landforms. Uh, the history of geomorphological mapping is like 100 years ago, and it was started like in 1914, and then there was others, especially for agriculture purposes and planning, city regional planning purposes. There were geomorphological maps that were used during the time of World War II. However, the present system that we see for the geomorphological mapping was quite recently, like around 70 odd years, and mainly the geomorphological mapping was started in some European countries like France, Poland, and Russia. And until today, there are many universities in France that are offering degrees in masters and PhDs in geomorphology, and it is very important. Geomorphology have you will see in the coming slides. It has applications to petroleum engineering. It has applications to petroleum geology. It has applications to mineral exploration. It has to soil sciences, to agriculture, and there are many subjects, especially also like as you have seen the start of boom in construction industry, the civil engineering, especially when you are constructing a dam or you are making a tunnel or some other engineering geological mega structures. You need to have a formal mapping system that can give you geomorphological maps. And there was establishment in 1960 for a subcommission of IGUS, that is the international standard system for geomorphological mapping. It was established quite recently, if you consider it in terms of the years. The main problem in having this system was the arrival at a specific legend, because, for example, one person in the United States is using another symbol for a river, and the same person or the other geologist working in Europe or in Australia or in Africa is using a different system, then it will be difficult for people to understand the message. That's why arriving at a uniform legend or a legend that you normally see on the side of the map to interpret the features in a map need to be agreed, and based on that map or based on that legend, that is like a standard, and then all of the world need to follow those standards. Okay, this is the symbol for river, this is a symbol for peak, this is a symbol of meander, this is a symbol of a small stream, a braided stream, and so on. The basic ingredients of a geomorphological map is that it should give information about morphology, the morphometry, morphogen, its genesis, and morphochronology of each of form. Just like whenever you see a publication or a research or a project in geomorphology, it will have different aspects. It can guide you regarding the appearance. Then it has the dimensions, the values of the slope, the origin of different geomorphological landforms, the age, like when a typical landform was formed, and these are different names that are given to the information that we can extract from the geomorphological map. However, these processes are quite complicated, and there is a software called ArcGIS, and this software is very useful. And I think you will study a subject, introduction to GIS. I think I shared a link in the group. I will try to send it again. You guys can use ArcGIS software, I think, until 30 June, free of cost. And I think you can download that software. I can send you the link. मैं आपको after the class I will try to search the link and I can send you in the group. Anybody who is interested to learn more about the software and to see how the software works for the geographic information system, and especially for the geomorphological mapping, you can explore the internet and see some videos on that. Okay. Right. Let me. So much. All right. However, the Comprehensive Geomorphological Survey, as stated in 1977, resulted three different kinds of maps. The first one is the analytical geomorphological map, then we have the synthetic geomorphological map, and the third one, the applied pragmatic map. Geomorphological map is the analytical map and applicable for mapping at all scales and serves as a basis for applied geological geomorphological mapping. And uh, it can be drawn or it can be made at different scales, and that shows different features at different scales, and that is called the analytical geomorphology. Sorry for the disruption. I think there was an internet connection problem. We continue. Okay. Then comes the there are some morphogenesis terminologies that indicate different processes and genesis. Like for example, there can be some geomorphological maps that can indicate an alluvial fan or a plain that has been made by alluvial fan. We call that as bead mount. Similarly, morphostructures and lithology, there are some information that can be given by the morphological maps in terms of lithology. As you have seen that different type of drainage patterns are associated with uh, different types of rocks, like if we have a granite or if you have a structural control on the landform, then it will have different structure and different shape. And in geomorphology we are dealing with the shape and the geology behind. And morphometry, it indicates the quantitative information about the relief, the height of the terrace and slope angle. All these features and all these aspects are represented by geomorphological maps that specializes in morphometry. So it is an applied type of maps, and mostly they are used in those areas where we have more erosion and where we have more weathering as compared to the areas where we have less erosion and less weathering processes. And you can also measure the carbon dioxide emissions, because faster erosion means faster release of carbon dioxide that is entrapped in the sediments, and as a result they move out of the rocks and they move out of the trapped material. Then comes the morphochronology. As you know, different processes on the planet Earth have different ages, and these landforms, whenever such information is available, you can make a morphochronological map. Like this hill was made 10 million years ago, this stream was made 20 million years ago, so and so on. There are some maps that we call the synthetic geomorphological map, in addition to the four maps that we discussed. And they can indicate information about the environment, especially, as you guys know, these days environmental sciences is a very growing science, and it can give you information about the environmental aspects of a certain area, and it can also include soils, hydrology, vegetation, land use, land cover, and topography, especially in those areas. Like, for example, in Islamabad, as you guys know, Islamabad is growing and it is moving towards the mountains, and it is moving towards the areas that were not inhabited before. And for that planning, you need proper geomorphological mapping and very accurate mapping, like centimeter with centimeter accuracy. And those maps are made in GIS software, and GIS is very helpful and it's the future. So I recommend you guys to actively see GIS as a potential future, because many of the geologists who specialize in GIS are working in urban unit in Lahore and in other places. So it will expand your job portfolio. You guys can also go to uh, different, especially Geological Survey of Pakistan or Survey of Pakistan, or even companies who are working abroad, because it will open new doors for you. GIS is the future. GIS is the most used uh, technique for mapping for geological, because you are geologist, so you have advantage that you know about the rocks, you know about the different processes, because you will study all these subjects in future. The applied geomorphological map or the pragmatic maps, they can also be drawn or derived from the analytical and synthetic maps. Maps related to the natural hazard assessment and developed for mitigation programs are increasing, becoming useful, as hazard zoning, which has a direct bearing on geomorphology, is possible in all cases. Also, like as we have seen the last in the last class, there was a map of flooded area, and there was a map before the flood. So as you see, there was an area that was, so you can calculate the damage, you can calculate the potential hazard, and you can try to avoid the hazard by proper planning and proper. So it is just like the government level decision making processes that you can also do with these type of maps. Okay. It also involves the mountain hazard zoning. As you guys know, there has been landslides in especially in Muzaffarabad or higher Himalayas. You see, roads are closing due to the mountain hazards. There can be drought hazards. You can do the mapping for agriculture areas, like if there is a threat of drought, or there is the water level is dropping so fast that it cannot catch up. Similarly, earthquake hazard zoning, like those areas that are in red zone, like for example in Islamabad or in Muzaffarabad, or Bav. Many of these places, as you guys know, even Quetta, the coastal areas of Kawadar, these areas are on red zone in terms of the earthquakes, and there are chances that in future or in there was earthquakes in the latest past, so there are probabilities that it can affect those areas, so it increases its ability. Volcanic hazard zoning, it's not that involved in our country, but if you talk about Indonesia or Italy or Mexico or Philippines, it is very relevant because they have a lot of these processes that has been going on, and that are continuous. Similarly, cyclone hazard zoning. Maybe you guys have listened. There was a cyclone in Bay of Bengal that affected Bangladesh, and it also affected parts of India. You can see that on the news, and you can also see that most of these hazards are explained by using maps, like how the cyclone is moving from one direction to another. मे बी आप लोगों ने सुना होगा कि ये जो साइक्लोन है ये पाकिस्तान दाखिल हो रहा है, या ये साइक्लोन जो है वो ओमान की तरफ जा रहा है या ईरान की तरफ जा रहा है. So that all involves the mapping, that all involves the techniques that are developed in the geomorphology. Oh, as you can see, geomorphology can be related to many sciences you can name, and it is a very wide subject. Other applied geomorphological mapping examples include maps for mineral and hydrocarbon exploration, which contains geomorphological anomalies indicative of suitable subsurface structures. Like, for example, whatever is in the subsurface will have its effects on the surface, and it has the potential. Like, for example, if there is an anticline in the subsurface, then chances that you will see linear features on the ground. And maybe oil companies who are interested to find hydrocarbons are interested in those type of lineaments or lines, and then they follow the trend, they go to the ground, they do the survey, and as a result of that they do the mapping, and then as a result of that mapping they select some structures, they go to the land, they do some field work, the ground testing, and then as a result of that they make some decisions, and based on that decisions they do the exploration. Similarly, mineral areas like Chaghi or Sandak areas in Pakistan, or those areas where we have some indicators of mineralization, these maps are useful in those areas. Similarly, radial drainage or compressed meanders may also be indicative of active buried structures that can be useful for mineral hydrocarbons. Like, for example, there was a river that was present, and you know, rivers are mostly filled with sand, and eventually those sands become sandstones, and in future those sandstones can be a reservoir of hydrocarbons. And if you have seismic section of those areas, like the ultrasound of that part of the earth, and then we just interpret, okay, this is the line we need to follow, and then we drill, and then we reach the hydrocarbon rich zone or maybe some mineral rich zone. Okay, there are some areas that have high recharge. Recharge are those areas where you have water that is going to the subsurface in the form of the groundwater, and it also shows you the based on the vegetation. As you guys know, vegetation is dependent on groundwater. So the type of vegetation, the strength of or the frequency of vegetation would also tell you about the groundwater. If the groundwater is saline, the vegetation cover will be different. If it is non-saline or it is fresh, then you will have different plants and different indicators. Like when I was working in Saudi Arabia, we went to the field and we saw some sand roses, and those sand roses are actually the gypsum that indicates the presence of groundwater in, in those areas, like 2 meter or 1 meter below the sand cover. These are some of the techniques. Similarly, some anomalously displaced terraces and alluvial fans are indicative of new tectonic activity, changing river courses, leading to anomalous lakes, and study of paleo drainages. indicative of climate and tectonic activity that have immensely benefited in understanding the phenomena through the knowledge of geomorphology. As you guys know, there are some features, geomorphological features, that determination of some terraces, alluvial fans are indicator of amniotectonic activity, and it can also be indicator of the paleo drainages. And paleo drainage is when we have like for example, as you guys know, there were some rivers that are closed due to the agreement between the two countries. Like there was a river that moves near Bahawalpur, Hakra River. It was now no longer active, but it still have the paleo drainage. However, these paleo drainages are still important because in subsurface there are some channels that are still working on, and they can be good for future of Bahawalpur area, and similarly some drought hit areas in Sindh. We can do these type of paleo drainage mapping, and those paleo drainage mapping can be helpful for understanding the future potential of groundwater in those areas that are hit by drought or that are hit by water scarcity. Traditional geomorphological mapping has been in practice ever since aerial photos become available. So this is mostly related to the aerial photos. Landforms have been the direct object of interpretation of aerial photos, and these are interpreted in terms of other themes like geology, soils. Landforms is the base of any geomorphological study. Based on the landform, then you understand the processes, and then you understand the rock types, and based on that, you understand the whole framework of the area, and then you come for your objective. Like if you want to do agriculture, or if you want to do the soil testing, if you want to make construction in that area, or civil engineering works, and so on and so on. Indicative and deductive reasoning is resorted to for interpretation of soil. For example, in pedological information is not directly seen, and it has been extracted from terrain features like landform, geology, vegetation, terrain. In some areas, the soil is covered with vegetation. Then, based on the vegetation cover, different colors and different style of vegetation, we try to understand the soil type. Similarly, some vegetations are or some plants are indicator of different minerals. Like for example, if there is zinc in the soil, or if there is manganese in the soil, then it will support different type of vegetation cover, and it will have different type of plants. Sometimes plants can help you to do the mineral exploration or hydrocarbon exploration, and they can guide you the way. That is just like the botanical side, or that is the side that can integrate with the uh, these features. We will continue our understanding in future next class about the remote sensing application. So this was uh, more about the types, and these are more about the different uh, sides of our study.